Have you ever noticed that your car suddenly loses power and the accelerator does not respond the same? The engine chokes. It is not a failure. Modern cars have protection modes that limit performance to prevent catastrophic damage to the engine, transmission, and critical components. Today we are going to identify the 12 exact reasons why your car enters protection mode or safe mode, and how to detect it before it takes you to an expensive workshop. This is valuable information to diagnose correctly, avoid unnecessary repairs, and understand why your car behaves in a strange way. Let us go there. Reason 12. Excessive engine coolant temperature. We start with reason number 12, excessive engine coolant temperature. Overheating activates thermal protection. The ECU constantly monitors the coolant temperature through the ECT sensor. When the safety limit is exceeded, typically 105 to 110 degrees Celsius, the ECU reduces power immediately. This protection prevents damage to the cylinder head gasket, cylinder head deformation, engine block cracking, and piston melting. The symptoms you will notice are the red temperature light on the dashboard, loss of throttle power, the engine with limited revolutions, and the radiator fan running at constant maximum speed. Common causes include low coolant level, leaks in the cooling system, thermostat stuck closed, failing water pump, clogged radiator, and an electric fan that does not work. For verification, use a scanner for the ECT sensor reading and compare with the actual engine temperature. If there is a discrepancy, the sensor is defective. Do a visual inspection of the coolant level in the expansion tank and look for leaks in hoses, radiator, and pump. The immediate solution is to stop the car and let it cool down. Never open the radiator when it is hot. Pressure and steam cause severe burns. A professional diagnosis is necessary to identify the root cause of the overheating and repair before driving again. Ignoring overheating destroys the engine completely. The repair costs thousands of euros. Prevention is economical. Reason 11. Excessive turbocharger pressure. In reason 11 we have excessive turbocharger pressure, overboost. This protection limits power. In turbo engines, the ECU controls the boost pressure via the wastegate valve or electronic actuator. When the pressure exceeds the programmed limit, the ECU cuts fuel injection and reduces power. This protection prevents engine detonation, which is a premature explosion of the mixture that damages pistons and valves. Symptoms are sudden loss of power while accelerating hard. The car accelerates normally and suddenly stops responding. Check engine light with code P0234, overboost. Causes include wastegate valve stuck closed, broken or disconnected boost pressure hose, defective turbo actuator, map pressure sensor with incorrect reading, outdated ECU software, and modifications to the turbo without reprogramming. For verification, use a scanner to read the fault code P0234 and the real-time boost pressure data. Compare with manufacturer specifications. Do a visual inspection of the hoses from the turbo to the intercooler, looking for breaks or disconnections. Verify that the wastegate valve has free movement without sticking. The solution: replacement of the wastegate valve costs between 300 and 500 euros. Repair of boost hoses around 100 euros. ECU reprogramming for turbo modifications between 500 and 1,000 euros. Ignoring overboost can destroy the engine due to severe detonation. Complete engine repair costs 10,000 euros or more. Reason 10. Throttle position sensor TPS with erratic signal. The throttle position sensor TPS with an erratic signal activates the protection mode with limited idle. The TPS informs the ECU of the exact position of the accelerator pedal. When the sensor fails and sends contradictory signals, the ECU enters safe mode and limits revolutions to idle at approximately 1000 RPM. This protection prevents uncontrolled acceleration, excessive revolutions, and damage to the engine or transmission. The symptoms are that the accelerator does not respond when pressing the pedal. The engine stays at low idle. Check engine light with codes P0121, P0122, P0123, TPS position out of range. The causes are worn sensor carbon tracks with irregular contact, TPS wiring short-circuited, loose or corroded connection, mechanically damaged sensor, and dirt buildup in the throttle body. For verification, use a voltmeter to measure the TPS signal. It should increase linearly from 0.5 volts at idle to 4.5 volts with full throttle. If it jumps or is intermittent, the sensor is defective. Cleaning the throttle body with specific spray can resolve the problem temporarily if dirt buildup prevents smooth movement of the butterfly valve. Reason 9. Insufficient fuel pressure. Insufficient fuel pressure when the pump, regulator or check valve fails activates lean mixture protection. The fuel system must maintain a specific pressure so that the injectors spray correctly. When the pressure drops, the ECU detects it via the fuel rail pressure sensor and reduces power to prevent an excessively lean mixture that damages the engine. This protection avoids detonation, excessive combustion temperatures, and catalytic converter failure. Symptoms are loss of power during hard acceleration. The engine shakes or hesitates under load. Hard starting, the engine turns for several seconds before firing. And check engine light with codes P0087, low fuel pressure, or P0190, fuel pressure sensor malfunction. Causes include a worn fuel pump that does not generate enough pressure, a defective fuel pressure regulator that allows pressure to fluctuate, a bad check valve where pressure drops with the engine off, a clogged fuel filter that restricts flow, and partially clogged injectors. For verification, use a fuel pressure gauge. Connect it to the injector rail and measure the pressure with the key in ignition and the engine off. It should be in specification. Typically 50 to 100 bar in direct injection engines, 30 to 50 bar in port injection. Listen to the fuel pump with the key in ignition. It should hum for 2 seconds to pressurize the system. If the pump is silent or does not work, check the fuse, relay and power supply. The solution. Replacement of the fuel pump in the tank costs between 400 and 800 euros, including labor for access. Pressure regulator between 200 and 400 euros. Fuel filter 50 to 100 euros. Ultrasonic injector cleaning between 300 and 500 euros. The correct diagnosis is essential to avoid replacing components unnecessarily. Fuel pressure as a problem can have multiple causes. Systematic verification saves money. Reason 8. Excessive engine oil temperature. Excessive engine oil temperature activates the thermal lubrication protection. Engine oil lubricates and cools internal components. When the oil temperature exceeds the safe limit, typically 130 to 140 degrees Celsius, the ECU reduces power to prevent damage to crankshaft bearings, camshaft and pistons. This protection avoids oil degradation, loss of viscosity, lubrication failure and engine seizure. Symptoms are loss of power during prolonged high-speed driving or with heavy loads, oil pressure or temperature warning light, oil temperature gauge in the red zone if available, and a smell of burning oil. Causes a low oil level with insufficient lubrication, old degraded oil that does not cool correctly, clogged oil cooler that does not dissipate heat, prolonged aggressive driving with a small engine and excessive load from towing or overloading and failing oil pump with insufficient pressure. For verification, check the oil temperature with a scanner. Oil temperature sensor reading and compare it with the specification. Check the oil level with the dipstick. It should be in the correct range between M- and max. Oil quality. If the color is black and thick, it is degraded and needs changing. Inspect the oil cooler if available, looking for obstructions, dirt or bent fins that impede airflow. The immediate solution is to reduce speed and load to allow the engine to cool down. Stop in a safe place and check the oil level. Add if necessary with the correct viscosity. Immediate oil and filter change if the oil is degraded costs between 100 and 200 euros. It prevents thousands of euros in engine damage. Moderate driving with reasonable loads and respected oil change intervals prevent excessive oil temperature. Maintenance is economical, protection is expensive. Reason 7. Excessive transmission temperature. Excessive transmission temperature activates overheating and gear change protection. Automatic CVT and dual-clutch DCT transmissions generate heat through friction. When the transmission fluid reaches a temperature that exceeds the safe limit, typically 120 to 130 degrees Celsius, the ECU limits power, makes smoother shifts, and avoids high gears. This protection prevents burning of clutches and friction bands, deformation of internal components, and catastrophic transmission failure. Symptoms are rough shifts or delays in gear changes. The transmission slips, revolutions go up but speed does not, transmission warning light, and loss of power during acceleration. Causes include low transmission fluid level with insufficient lubrication and cooling, old degraded fluid that does not dissipate heat correctly, clogged transmission cooler, towing heavy loads or prolonged climbs, and city driving in heavy traffic where frequent shifts generate excessive heat. For verification, check the transmission temperature with a scanner. ATF temperature sensor reading and compare it with the specification. Fluid level with the specific transmission dipstick in the correct range. Fluid color. If it is dark brown or burnt black, it is degraded and needs changing. Do a visual inspection of the transmission cooler and cooling lines looking for leaks, obstructions, or damage. The immediate solution is to stop the car safely and let the transmission cool for 10 to 15 minutes before continuing. Transmission fluid and filter change costs between 200 and 400 euros depending on the vehicle. Full transmission service including cleaning costs between 500 and 1,000 euros. The installation of an additional aftermarket transmission cooler between 300 and 500 euros improves cooling capacity in vehicles with frequent towing. Preventive maintenance with transmission fluid changes at recommended intervals, 30,000 to 60,000 kilometers depending on the type of driving, prevents costly overheating and avoids transmission repairs of 5,000 to 10,000 euros. Reason 6. Clogged DPF anti-pollution system. The anti-pollution system with the DPF, the diesel particulate filter, clogged forces a regeneration and activates protection. Modern diesel engines have a DPF that captures soot particles from the exhaust. When it becomes excessively clogged, the exhaust back pressure increases and the ECU limits power and forces a DPF regeneration to burn off the accumulated soot. This protection prevents damage to the turbo, EGR valve and engine. Excessive back pressure destroys components. Symptoms are gradual loss of power, especially during acceleration. The engine chokes, excessive black exhaust smoke, DPF warning light on the dashboard, strong exhaust smell during the regeneration process, increased fuel consumption, and high exhaust temperature. Causes include short-distance urban driving where the DPF never reaches regeneration temperature, incorrect quality engine oil that generates excessive ash and clogs the DPF, defective DPF differential pressure sensor with incorrect reading, and worn fuel injectors where incomplete combustion generates excessive soot. For verification, use a scanner to read the DPF status. Percentage of obstruction, differential pressure before and after the filter, and data on completed or failed regenerations. You can force a stationary regeneration with a scanner procedure that keeps the engine at high revolutions with the necessary temperature to burn the soot for 30 to 40 minutes. The solution, professional DPF cleaning with a specific machine, costs between 400 and 600 euros. New DPF replacement between 1,500 and 3,000 euros depending on the vehicle. For prevention, do highway driving at constant speed for 20 to 30 minutes weekly. This allows natural automatic regenerations. Use engine oil with the correct low SAP specification, low ash, and respect change intervals. DPF removal is illegal in Europe. It fails the technical inspection with fines. Additionally, it damages the turbo and the EGR valve in the long term. The solution seems attractive but creates bigger problems. Reason 5. Contaminated MAF airflow mass sensor. The airflow mass sensor, MAF contaminated, gives an incorrect air-fuel mixture reading and activates protection. The MAF measures the exact amount of air entering the engine. The ECU calculates the fuel to inject. When the sensor is contaminated with oil, dust, or residues, it sends an incorrect signal and the ECU injects the wrong fuel, excessively rich or lean mixture. This protection avoids damage to the catalytic converter, abnormal combustion temperatures, and engine detonation. Symptoms are loss of power, poor acceleration. The engine starts with difficulty, unstable and irregular idle, fuel consumption that increases drastically. And check engine light with codes P0100, P0101, P0102, MAF circuit malfunction, or P0171, P0174, lean mixture. Causes a dirty air filter where particles pass and contaminate the MAF. High-flow air filter oil with excess applied that contaminates the sensor. Crankcase oil vapors from defective PCV ventilation, and old MAF where the hot element is degraded with reduced sensitivity. For verification, use a scanner for real-time MAF data. At idle, it should mark between 2 and 7 grams per second depending on the engine. During acceleration, the values increase proportionally. If the reading is 0 or excessively high, the sensor is defective. Cleaning the MAF with specific MAF cleaner spray, never brake cleaner or WD-40 because it damages the sensor element, is applied carefully to the hot wire or hot film element. Let dry completely before reinstalling. The solution: MAF cleaning costs between 15 and 20 euros and can restore sensor function if contamination is minor. MAF replacement between 150 and 300 euros depending on the vehicle. Some sensors are expensive, €500 in premium brands. For prevention, use a quality air filter changed at the correct intervals, 15 to 20,000 kilometers, to avoid MAF contamination. High-flow air filters require oil. Careful application without excess contaminates the sensor. Maintenance of the PCV crankcase ventilation system with the valve working correctly prevents excessive oil vapors. Reason 4. Engine detonation detected by the knock sensor. Engine detonation with knocking, where the knock sensor detects it, activates protection with ignition delay. Detonation is a premature and uncontrolled explosion of the air and fuel mixture in the combustion chamber. It generates pressure waves and metallic knocking. The knock sensor detects the specific vibration, and the ECU immediately retards the ignition timing and reduces power to prevent damage. This protection avoids holes in the pistons, burned valves, cracking of the cylinder head, and catastrophic damage to the engine. The symptoms are loss of power during hard acceleration, especially on climbs with engine load, metallic knocking sound from the engine underload when accelerating hard, and check engine light with codes P0325, P0330, knock sensor circuit malfunction. The causes are incorrect octane fuel, low for what the engine requires, such as if the engine needs 95 gasoline and you use 90, detonation is inevitable. Spark plugs of incorrect thermal range with excessive combustion temperature. Carbon accumulation in the combustion chamber that increases compression, defective knock sensor that does not detect real detonation and the ECU does not protect the engine, and turbo with excessive boost pressure where overboost generates detonation. For verification, check the fuel in the tank with the correct octane according to manufacturer specification. Spark plugs with gap in specification and correct thermal range. Inspection with a bore scope of the combustion chamber to see carbon accumulation on valves and pistons. The cleaning of the combustion chamber with carbon accumulation using the walnut blasting procedure in specialized service costs between €500 and €800. Fuel cleaning products or continuous use additives prevent accumulation. Replacement of the knock sensor costs between €200 and €400 depending on the location and accessibility. In some engines, the sensor is under the intake manifold with intensive labor. The immediate solution is to use higher octane fuel, 98, temporarily while you diagnose the problem. Gentle driving, avoiding hard acceleration and excessive load. Ignoring detonation destroys the engine quickly, hold pistons, burned valves. Complete engine repair costs between €5,000 and €10,000. Prevention is economical, correct fuel and proper maintenance. Reason 3. Manual transmission clutch slipping. The manual transmission clutch slips and overheats, activating protection with power cut. Worn clutches do not transfer engine power to the wheels correctly. They slip and generate excessive heat through friction. The ECU detects the difference between engine speed and transmission input speed using RPM sensors and cuts power to prevent damage to the clutch disc and engine flywheel. This protection avoids complete burning of the clutch, crystallization of the disc with impossibility of changing gears, and deformation of the pressure plate where the flywheel needs resurfacing. The symptoms are the clutch slips. Engine revolutions go up, but vehicle speed does not increase proportionally, especially on climbs or hard acceleration. Characteristic burning smell of the clutch pedal with spongy feel and high engagement point, and loss of power during acceleration. The causes are worn clutch disc with spent friction material and smooth surface that slips, pressure plate with weak springs that does not apply enough pressure, engine oil that contaminated the clutch disc due to a crankshaft seal leak, engine flywheel with irregular surface and uneven wear, and aggressive driving with sudden starts or semi-pressed clutch that generates premature wear. For verification, do a road test on a steep climb. In a high gear, 3rd or 4th, accelerate fully. If the engine revs but the vehicle does not accelerate correspondingly, the clutch slips. Inspection. Access to the clutch requires removing the transmission with intensive labor. Verify the thickness of the clutch disc, condition of the pressure plate, release bearing and engine flywheel. The solution: replacement of the complete clutch kit, disc, plate and bearing, costs between €600 and €1,200 in parts. Labor costs between €400 and €800. The total, between €1,000 and €2,000 depending on the vehicle, whether it is front or rear wheel drive and the complexity of access. Resurfacing the engine flywheel if the surface is irregular costs between €100 and €200 additional. Reason 2. ESP traction and stability control system intervenes. The ESP traction and stability control system intervenes by cutting power for stability protection. ESP and TCS electronic stability systems constantly monitor wheel speed, steering angle, and lateral acceleration. They detect loss of traction or skidding. The ECU reduces engine power and applies brakes to individual wheels to regain control of the vehicle. This protection prevents loss of control, accidents, road departures, and rollovers, especially in adverse conditions such as rain, snow, or ice. The symptoms are loss of power accelerating in a curve or on a wet road. ESP light flashing on the dashboard. The engine cuts power momentarily while the wheels slip. Sound of brake application like the ABS with pulsation in the brake pedal. And the vehicle stabilizes automatically. The causes are excessive acceleration in a curve where the drive wheels lose traction and slip, wet, slippery road, ice or snow with reduced traction, worn tires with insufficient tread and poor surface grip, incorrect tire pressure, low or high, that affects contact with the road, and defective wheel speed sensor that sends an incorrect signal and the ESP activates unnecessarily. For verification, the ESP light on the dashboard flashes actively during normal operation. If it remains permanently on, there is a defective wheel sensor or fault code in the ECU memory. Tires. Visual inspection of the tread. The legal minimum depth is 1.6 mm. The recommendation for safety is 3 mm. Tire pressure according to manufacturer specification on the driver's door or manual. Deactivating the ESP with a button is available in some vehicles for specific situations. Stuck in snow or sand where you need to allow the wheels to slip to get out. Use responsibly. On a normal road, the ESP must remain active for safety. The solution is driving adapted to road conditions, moderate speed in curves, smooth and progressive acceleration, especially in the wet. Replacement of worn tires, €200 per quality tire. Wheel speed sensors between €100 and €200 each. Cleaning ABS sensors if accumulated dirt or rust restores function. Reason 1. ECU detects critical failure and enters safe mode limp mode. And we reach reason number 1. The ECU detects a critical system failure and enters safe mode limp mode with maximum protection. Safe mode or limp mode is the ultimate protection of the ECU when it detects a serious fault that can cause catastrophic damage to the engine, transmission, or vital components. The ECU severely limits power. Typically, maximum revolutions are 2,000 to 3,000 RPM, maximum speed of 50 km per hour. It allows driving to the workshop safely without destroying the engine. This protection avoids irreparable damage to the engine, transmission, and expensive components. It allows diagnosis and repair before total damage. The symptoms are severe and drastic loss of power. The engine does not exceed 2,000 revolutions. The accelerator practically does not respond. Permanent check engine light with multiple fault codes stored. Transmission locked in a single gear, typically second or third, and the vehicle barely moves at minimum speed. The causes are multiple and simultaneous. Critical sensors failing such as the MAF, TPS, ECT, crankshaft or camshaft position sensor. Serious transmission problems, the TCM, transmission control module with communication failure. Extremely low engine oil pressure due to sensor or pump failing. Turbocharger with complete failure or wastegate valve stuck. Oxygen sensor or catalytic converter with serious emissions failures. Electrical system with battery or alternator voltage unstable, low or high. For verification, use a scanner to read all fault codes stored in the system. Engine, transmission, ABS, ESP. Multiple simultaneous codes indicate safe mode. Freeze frame data from the moment of the failure provides information about the conditions when the ECU activated the protection.